Okay, in this video we are going to look specifically at some reviews in terms of linear equations. When we're talking about linear equations, we always have to start at the basics, and the basics means you start back down at slope. We designate slope with the letter M. Okay, and what we have to remember about slope is that it is your change in y over change in x. Now, if you're looking at this through the eyes of pre-calculus, we're going to start to get into terms like the slant of a line instead of calling it slope. Because that's what we're doing. We are looking essentially at the slant of a line, and we're talking about what its grade is or how much it's actually slanting. There's a couple ways that we can find and work with slope. The first is using just the good old-fashioned formula. Change in y over change in x, and then you reduce your fraction as low as it can go. We can also use slope from an equation. So here we have the slope-intercept form, and so slope being my m value, that would be the number attached to your variable. Okay, and then obviously b is that y-intercept. So if we want to use the slope given the equation, we just simply have to pick it out of the equation. The third way is that we have special functions. Now, in terms of slope, we only have two special functions. First would be the zero slope. So notice it's a horizontal line. And the reason for that is because you are not changing your y value at all. Therefore, 0 is on top, making your slope a 0. The other special case, and the one that tends to trip most people up, is the undefined. Notice we have this vertical line here. The reason it's undefined is because if you look at the equation, my 0 is on the bottom. And if we know anything about fractions, the number one rule is that you cannot have a 0 in your denominator. So what we're going to do is we're going to look at a couple examples here on being able to calculate your slope given some different parameters. So in this first one, notice I'm giving you two different coordinate points, and we want to calculate the slope between them. So simply what you have to remember is that you're going to have your slope is going to be the change in y over the change in x. So when you're looking at your points, you have to designate one point to be x1, y1, and one point to be x2, y2. It doesn't matter because it's all going to work out in the end. So if we make this x1, y1, and then we have x2, y2, we simply have to plug our points into the slope formula. So here, remember, change in y means y2 minus y1, so this is negative 6 minus 8. And then we have x2 minus x1, so this is going to be 7 minus a negative 9. Now we have a rule that says minus a negative becomes positive, so this would change to a plus. And then we simply reduce or do the math. So 6 minus 8 is going to give us a negative 14 on top. 7 plus 9 gives us a positive 16. And then the biggest rule we have to remember is to reduce. So when we're looking at this, my slope is going to actually reduce. When I'm talking about 14 and 16, what I have in common there is a 2. So divide that 2 out and you get negative 7 over 8, and this would be your slope result. Now, the other way that we can work it is if we're given an equation. And notice with this equation, I have a fraction here. So the first thing that you want to do is you want to remove the fraction by multiplying the whole equation by that denominator. And the reason we can do that is because I don't have any other denominators here. By doing so, it means this 3 gets applied to all parts. So when we're talking about this first part, it means your denominator goes away and it's going to leave us with x plus 2. When we're talking about this second part here, we're going to just simply apply it to the 2. And the reason is because I have not distributed it through yet, so we're going to apply that 3 to the outside. So 2 times 3 gives you a 6, so this is plus 6 times the 1 minus y. Put in your equals, and then I have negative 2 times 3 is a negative 6x. And now we need to get all my y's on one side and all my x's to the other. And so here we need to go ahead and distribute the 6 through. So this becomes x plus 2 plus a 6 minus a 6y equals negative 6x. And so here I need to combine my terms. So I'm going to combine these two middle terms here. This becomes x plus 8 minus a 6y gives you that negative 6x. I'm going to go ahead and take my x here, and I'm going to move it across my equal sign. Because it's positive, to move it means I have to subtract. So this is going to give me 8 minus my 6y equals a negative 7x. I also now need to take this 8 and move it. Again, the same thing, because the 8 is positive. To move it says I have to subtract. So this becomes negative 6y equals a negative 7x minus 8. I need to get y by itself, so I'm going to divide the whole thing by a negative 6. And in doing so, I get this y completely by itself, so this becomes y equals. Negative over negative is positive, so this becomes 7 over 6x. Negative over negative is positive, so this is going to be positive. 8 over 6 becomes 4 over 3. And if you remember, we wanted the slope. So here, the very last thing you need to do is identify what you wanted. So in this case, my slope is going to be 7 over 6, and this was what we were looking for. So whether you are given coordinates or given an equation, the root math is going to be the same, in that you need to identify the slope that you have. Now, another part that we work on with linear is being able to graph, and there's a couple ways to graph. This first is looking at using the slope and the y-intercept. So in order to do that, we use the Y-intercept form, so y equals mx plus b, where m is the slope and b is the y-intercept. Now, with this, you want to note that you must always write intercepts using the proper form. What that means is that a y-intercept is always going to be 0, y. It is never going to be y equals. Okay? So always make sure that you use the proper form when identifying a y-intercept. So here we're going to look at graphing the equation using the slope and y-intercept of the given line here. So we have 2x minus 3y equals negative 12. So the first thing we need to do is we need to solve this equation for y. So I'm going to move my 2x, so this becomes a negative 3y is equal to negative 2x minus 12. I need to divide the whole thing by negative 3. Gives me y is equal to, again, negative over negative becomes positive, so this is 2/3 x. And then 12 over 3 becomes positive 4. Now that we have the equation of our line, what we need to do is identify the pieces. First of all, we need a slope, so this is going to be 2/3. And then we need your y-intercept, so that is going to be the point 0, 4. You're going to graph your y-intercept first. So you're going to come over here and you're going to go ahead and graph your point. So 0, 4, 1, 2, 3, 4. And then your slope is going to be change in y over change in x. So because this is a positive slope, remember both are positive, so you would go up 2 over 3, or you can reverse it. We can go down 2 in the negative and 1, 2, 3 in the negative. So either way works. You need 2 points in order to graph a linear line. Once you do, you then connect those dots and draw your linear line. Okay. Now, you don't necessarily have to use a ruler, but you do have to be as close as you possibly can. So here, this would be the linear line we're looking for. Now, our line was positive, so you want to make sure that your line that you drew was going in the positive direction, which this one is. Let's look at another one here. In this case, again, I still have to solve for y, so I'm going to take this x and move it. So this becomes 5y is negative x plus 20. Divide everything by 5, and you end up with y being negative 1/5 x plus 4. Again, we need to identify our information, so here we have that my slope is negative 1/5. My y-intercept is the point 0, 4. And so once again, we're going to go ahead and draw our intercept point at the point 0, 4. And then in this case, I have a negative, which means either the top or the bottom is negative. So you choose. I usually like to make my y values the negative piece. So in this case, I would go down 1, but then I need to go positive 5. 1, 2, 3, 4, and 5. We could do the same thing if you had gone the other direction. We could have gone up 1 and then negative 5. 1, 2, 3, 4, 5, which would put it right here. Again, you only need 2 points in order to graph, but the more the merrier. And so here, once you've got your points, you then connect your dots and you've drawn your linear line. Last, always make sure you put your arrows on the end to signify that that line is traveling forever in infinite directions. Now, another big concept that we use with linear equations is being able to write the equations of lines based on information that has been provided. So we've got a couple different lines that we can work with. First is what's called standard form. So notice with standard form we have ax plus by equals c. There's a couple rules that we have to follow when using standard form, so do make sure that you pay close attention to them. The first rule is that you cannot use fractions or decimals. In this equation, we're talking about good old-fashioned whole numbers. The second rule is that the sign of the x term must be positive. So when we're talking about the sign of the x term, what we're actually saying is that ax must be positive. Therefore, if it ends up being negative, the last thing you would need to do is divide out that negative in order to make it positive. Okay, i.e. flip all of your signs. Now the other form that we have is one we've already talked about, slope-intercept form. So remember, that's y equals mx plus b, where m stands for your slope, b stands for your y-intercept value. With this line, we don't actually have any kind of special issues, requirements, stipulations, rules that you have to follow. It's a good old-fashioned line to be able to use. The third line that we have is a line that's actually called point slope line. It is the line or the equation that is used to find equations of lines. So this line here, notice I have y minus y1. So essentially when we're talking about the y1, this is going to be your coordinate point. And the same with the x1. This is your coordinate point. So what that means is that y and x here are cemented in place. So if you look at slope-intercept form, notice I have y and x. So that's the same thing here. What we're doing is trying to find the equation of the line. And then obviously that m again stands for your slope. So when you're trying to write the equations of lines, you really have to look at the information provided, and then you have to decide which line is going to best fit the information you've been given so that you can actually write your equation. So let's look at an example here. In this first one, it says that we need to find the equation that fits the given information and then write the answer in both standard form and slope-intercept form. So in other words, what we're talking about is that we want to know ax plus by equals c, and we want to know y equals mx plus b. Okay, that's what we want. So here we've just been given 2 points, the point 7, 7 and 9, negative 8. So the first thing we have to do is we need to find the slope. Again, change in y over change in x. So to do that, again says we have to determine or specify what's going to be x1, y1 and what's going to be x2, y2. So it doesn't really matter. We could do x1, y1, x2, y2, or obviously you could flip and you could have used the other points too. So it's personal preference. You just need to declare something. So here change in y says we're going to do y2, so negative 8 minus y1 all over x2 minus x1. So in this case we have negative 8 minus 7 is going to be a negative 15. 9 minus 7 gives you 2. So my slope is negative 15 over 2. So here I have 2 points to choose from and I have a slope. So what I want to do is I want to use y minus y1 equals m times x minus x1 in order to find the equation of my line. I can choose either of these points to use. It really doesn't matter. It is totally personal preference. I'll go ahead and use my first point here. So I'm going to have y minus 7 equals negative 15 over 2 times x minus 7. So here, once you plug everything in, we need to distribute. So we're going to distribute this fraction through. So this gives us y minus 7 is equal to my negative 15 over 2x. And then I'm going to multiply by that 7 here. So we're going to have 15 times 7 gives you 105. Negative and negative is positive, so this is going to be positive 105 over 2. And then we need to go ahead and take this negative 7 and move it. Because it's negative, to move it says I have to add. So this becomes y equals negative 15 over 2x plus my 105 over 2 plus my 7. Now here I need to combine my fractions. So when I'm looking at this right here, I need to combine my fractions. So to do that, says I need to have common denominators. So this is 105 over 2 plus common denominator would be 2, so this becomes 14 over 2. When I combine those, I get 119 over 2, thus leaving me with y equals negative 15 over 2x plus 119 over 2. This line right here is going to be that slope-intercept. So I have one line down, I have one line to go. Now in order to do this, the first thing we need to do is we need to remember I cannot have any fractions. So the first thing I would do is I would multiply everything by 2, thus getting rid of these denominators. So here this is going to become 2y is equal to negative 15x plus 119. Then the last thing I need to do is move my x back over. Because it's negative, to move it says I have to add. So this becomes 15x plus a 2y equals 119. This equation right here is your standard form. So we have our first solution or first equation in slope-intercept form, and then we use that slope-intercept form to find my standard form. Alright, so if you have any questions, please let me know. Otherwise, make sure to enjoy yourself, watch your fractions, and I'll see you next time.